Good morning, everyone. I'm Nicole Testa-Boston, the Deputy Director of the FIATech Consortium. And on behalf of all of us at FIATech, I want to thank you for joining us today. We have an exciting hour set aside to talk a little bit about the ProStar Online online system. FIATech awarded the ProStar Online System a SETI Award at the Arizona Conference this past April in the category of Real-Time Project and Facility Management, Coordination, and Controls. And as we're doing with the other recipients as well, we wanted to provide a webinar hour where we could learn in more detail about the award recipient and the work that they're doing. Before we get started and I introduce our two speakers, I want to go ahead and just give a brief orientation on the GoToMeeting system for those of you who may be using this for the first time. You will notice you have a toolbar. That toolbar is unique to you. Only you can see that, and you can minimize it or maximize it as you wish by clicking on the orange arrow tab on the side of that toolbar. If you click on that, it'll minimize off your screen, and you'll have an unobstructed view. If at any time you want to use that, you can simply click on the arrow. That will then be pointing to the left and bring that back up. You'll also notice that you have default mute settings. That's due to the number of attendees on this call and a function of the Citrix system. So we do encourage and we do welcome questions by using the questions tab on the toolbar. So if there's anything as the presentation is going on that you'd like further clarification on or questions on, please just type those in. Those will come directly to me. I will not share who's asking the question or from which company. You'll remain anonymous, and I will forward those questions to our speakers today who, as time permits at the end of the hour, will answer them. We also, if we run out of time, will follow up with you separately. And last but not least, I want to mention that we are recording this seminar, both the audio and the visuals, and we'll post that on the FIATech Media Library at fiatech.org later this week. It usually takes a couple of days for us to package it and post it, but it is free and available to anyone. So with that, I want to get started and introduce Paige Tucker. He has an extensive background in startups, including marketing, recruiting, capital financing, and executive management of early-stage technology businesses. Formerly, Mr. Tucker was the founder of Impact Solutions, a Charlotte, North Carolina-based company founded to provide state-of-the-art database solutions and GIS services to the automotive retail industry. He's also the co-founder of eAuto Business, which is a provider of CRM web-based data services to over 900 dealerships throughout the U.S., and he served as CEO through the critical formative years until he resigned his position in 2003 to form ProStar, Inc., and he currently serves as the CEO and president of ProStar. Mr. Mark Beckner is joining him and us as well today. He's the business integration specialist who has worked with numerous startups to Fortune 500 firms, EAI and B2B systems using a wide variety of technologies and languages. He has extensive experience in all aspects of the development lifecycle and requirements gathering through design, development, documentation, quality assurance, and support. He's responsible for architecting ProStar Online, ProStar's electronic data management and storage and distribution via the cloud or application service provider model. He earned a number of awards and professional certifications from Microsoft, including Microsoft Certified Solution Developer from Microsoft.net, and has spoken at a variety of venues, including Microsoft Tech 2008 and 2009. He's the author of the Pro EDI in BizTalk Server 2006, R2 Electronic Document Interchange Solutions, and co-author of Pro RFID in BizTalk Server 2009 and BizTalk 2006 recipes. So thank you both very much for joining us today, and let me turn it over to you to get started.
That's great. My name is Paige Tucker. I appreciate everybody for giving us the opportunity to present our system today. I think what we'll do is we'll just go through a quick PowerPoint presentation, which basically outlines what we're going to be taking a look at today when we actually go into the portal and take a look at our technology. Mark, why don't you just go ahead and be the presenter as we go through the PowerPoint. I will just go through it, and then we'll go right into ProStar Online, and we'll demonstrate the technology.
Good.
There's a major problem facing our nation's infrastructure, and that is that there has been upwards of $100 billion spent in mapping above-ground infrastructure over the last 10 years, according to some industry statistics. But there's been very little money that's been spent on mapping what lies beneath the earth. And with a lot of major developments taking place as we expand roadways, highways, we're building more schools, we're building more shopping malls, the population continues to grow. It's exerting a tremendous amount of pressures, if you will, on the below-ground infrastructure as those corridors below ground become somewhat congested. And as a result, as we're adding more and more to that infrastructure, which is also aging, it's very difficult to know exactly what lies beneath the earth. And it has been causing some major problems, which over the last few years have become much more prevalent, and as we see on the news, can cause major problems, including even loss of life and limb and major damages to our environment. So basically what I have here, it says our nation's utility network is aging, it's rapidly expanding, and much of the underground space in which it lies is becoming seriously overcrowded. To make matters worse, where and what actually lies beneath is unknown with any level of certainty. Not knowing precisely what lies beneath is of great concern to both the construction and utility industry as the demands to increase our nation's infrastructure continues. Marky, can you go to the next slide?
It's up.
I just checked out on my software, so just hang on a second here. Okay, I'm going to minimize this. Let's see here. No, did it again. Hang on one second here. Just hang on one sec here, Mark. I'm hitting the minimize and it's checking me out. Strange. I can't see the PowerPoint. I'm clicking the minimize button and it's checking me out each time.
Well, you've got the PowerPoint there local, so go ahead and just open up a local copy of GoToMeetings, kicking you out.
Okay, it's a good idea. I don't know why it's doing that. Okay, I'm on the second PowerPoint right now, so we'll just follow along. Let's take a closer look at the problem. In the United States, there is over 35 million miles of buried utilities. And each year, there's over 20 million excavations. News reports of significant damages and loss of life and limb are becoming far too routine, and taxpayers pay billions of dollars each year in repairs, lost wages, emergency responses, and environmental cleanup. The missing piece of the puzzle. ProStar feels it has developed a comprehensive solution that addresses this immense and growing concern. Our system is innovative, easy, and affordable. ProStar's innovative, easy-to-use, and affordable system is designed to improve all phases of the project lifecycle for the utility and construction industries. Our system features, it's web-enabled, it operates on a cloud network, it integrates GPS, GIS, and mobile technologies, it integrates with orthophotography, it's hardware and software agnostic, it's easy to adopt, it's affordable, and it's also patented. Now, Mark, why don't we go ahead and we'll dial into the system, and I'll just explain basically what we're going to take a look at now.
Sure.
We spent the last 7 years developing a system, a web-based system that basically sits on servers at Rackspace. Rackspace hosts 40% of the Fortune 100 companies' data. So the system is very secure, very robust, with unlimited scalability, including globally. And what we did in 2004, when we actually started developing the system, is that we realized all of the problems facing the utility industry, realizing that there's a lot of damages that occur to our utility infrastructure during construction. There's a little adage out there, a cliche, that says that the #1 locate tool in the United States is actually the shovel or the bucket of a backhoe, which, as humorous as that is, also causes some serious problems. What we did is realized is that the problem is that there was all of these utility lines that were buried below the ground, but there was not a precise mapping system that was being utilized by the utility or construction industry to identify precisely where those utility lines were located. And the process in which locates were actually facilitated was far from being an exact science. In many cases, they would have to go out onto the construction site. They would take paper maps out there, try to identify where the utility lines are. Markings were temporary by nature when, if they could identify where the lines are, they would use spray paint markings on the ground and spray those markings precisely where construction was going to take place. So within a matter of minutes, most of those markings disappeared, and then they would continue, because it was mainly contractors that were out there, which are pretty much bid on the job, so they're getting paid based on the efficiencies that they can create. So they weren't going to sit around on the job waiting for those markings to be remarked to know where the lines are. And it's pretty much been that way for years. It's very discombobulated. It's a fragmented system. And we knew there had to be a better way, and that the way to address that problem was to be able to go in and create a data management system that would create collaboration between all of the stakeholders involved. And we also realized that we weren't going to be able to go in and change all of the current business practices and their methodologies, so we were going to have to create a system where we could integrate with all of the legacy technologies, all the legacy business practices and methodologies that existed, and also create a system that could also adapt as new future technologies came to market. And that is exactly what we have developed over the last 7 years. We've been involved in a couple of major projects to test our system, and we feel confident today that we're ready now to work with the construction industry on facilitating various projects to host those projects online through a web-based system. We also know that it appears that GIS and CAD operations are moving to a point where it appears that those operations will be working online, and we think we've designed the system to facilitate that. So, Mark, I'm going to let you go ahead and describe this current project and how we utilized our system and exactly what it is that you're logging into.
Sure. So as you mentioned, this is an implementation or an aspect of what we can do. A lot of what we do is sort of behind the scenes at the database level or at the integration tier. And so having a portal allows us to sort of represent and report on some of that data. And this portal was used specifically for a client project, but is only a small aspect of really what's going on behind the scenes. So what we've got here is the web page that we're logging into, and really what this did for the client is there are several aspects where the data is coming from. First, we were getting ticket information from the one call center, and so in any given day there could be hundreds of tickets that are coming in. And there's a filter put into place to determine what tickets do we want to be out to an FTP site. We go grab that with BizTalk and some other processes. We bring it into the server, and we do a variety of business rules and business checks on that data before we insert it into various underlying SQL tables. And all of those, all that data is represented in pure geospatial XML at the database level, so we get all the new functionality from SQL Server and the other tools. But we bring that ticket data in, and then we can see a polygon. You know, imagine a square on the screen that says, here is where this ticket is occurring. And then I'll bring that up while chatting. So the ticket represents a dig area, and then there's several other pieces of data that are coming in from parties. There's a locate company that is actually out in the field with their locate device collecting that information and exporting it to us via both web service and FTP. There's actually two companies that are doing those locates. So the locates are coming in from various locations. We're also getting information from Trimble Web Services about how equipment that's out in the field is using a specific tool for this project that's uploading XY coordinates of the backhoe digging. And so we're getting all this data in from various locations, and we're sort of compiling it on the back end and trying to make a picture of what's going on so that project managers can log in and see it. And here's a very, very simple representation of a ticket area. So the defined polygon boundaries, there was a photo for this specific one. Just basic photo capturing capabilities tied into there. And then there's also, in this case, this was a moment in time when the equipment uploaded its location during a dig. So we know where it was, and we can put together a report that sort of traces that movement of the equipment over time. Any given period of time, we can say, show me how this thing moved in and out of the bounds of the ticket, etc. We've got all sorts of different layers that we can report on, but I'll bring up a different report so we can see that a little bit better. The most interesting one here is the locates. So we'll bring up first the ticket with locates. And if you see down here at the bottom all these little flag markers, these are actual locations where one of the locate companies was going through and saying, here is the original location of this pipe. We're uploading the information and all the information about it. So when did we receive it? Here's just some of the metadata that we're getting and displaying right now. But this is really limited only to what the data collector is actually pushing up. So it could be water, sewer, whatever we want to see on there. So those are all the locates. And then we also have, in this case, this black line is indicating the distance between where the equipment is at a given moment in time. So this was, for this report, the last moment that we got information from this equipment for this project. Where was it towards the nearest located utility? And we mark all that information about, how far away is it, and we can put together notifications based on encroachment. So is this thing getting within X number of feet or meters of the nearest utility? Send out alerts either to the local backhoe operator or to the project manager, someone who can make some immediate decisions as to what to do.
Mark, if I can interject.
Yeah.
In this case right here, what we've done is we've integrated this project management tool in with the one call state call before you dig system. And basically what Mark was showing you there is that red depiction, if you will, that colored area is the construction zone. So that's the project site dig area where a contractor has indicated that he needs to dig in that area. So then there's a one call ticket that's generated. In the past, that would be something that would be printed out on paper and then faxed or transmitted to somebody, and then they would actually have to go out and do the markings, but they would do it blindly. They wouldn't actually know where they're marking. So in a lot of cases, and what Mark is showing you here, is that there's actually been some locates that were done outside of that dig area, which means those locates actually were not necessary. The way we're designing this here is actually, the idea is that we're enabling to take GIS, or if you will, spatial information or mapping information, actually out into the field so that the construction workers can actually see what they're doing out in the field and where they're having to do their locates, where the utility lines are, but also from the point of view of the locator, they can then see on a map reference. In this case, we've integrated with Google on an API. They at least now have a topographic view of where they are out onto that construction site and where they should be locating and exactly what it is that they are locating. So what this would allow the locator to do for the first time is to actually see where they are out on the construction site and what it is they're locating. And then while they're out there, if they identify some other features that maybe they think that they should locate or map, then they can go ahead and grab those features as well. So if you take a look at this from a construction perspective outside of one call, that red area could be a construction zone that is, say, half a mile wide, or it could be 10 miles wide. And then we could gather all the information associated to that specific area that's been identified. So basically, as Mark said, it's a business rules system. And so the information that we're utilizing here and that we're gathering is specific to what the one call has set up here in the state of Virginia. Now in the past, when you went out and did the markings and located the lines, that information, as I mentioned, and I'm sure some of you are familiar with this process, they spray those markings on the ground and then they leave and then that's it. The next time somebody's going to do construction in the area, then that whole process begins over again. So no one has ever actually gone out and recorded that information, mapped it, sent it to a database where you could go recall that information the next time you had to go out there. And then the idea being is that each time you go out there, if there's more and new information added to the system, then as a transactional database, we store that data, and then we can inform the people that need that information that there's been new data that's been acquired, and then they can go and take a look at it. If that information improves the data that they had in the system, then they can replace it with this new data. But as a transactional database, we never lose any of the previous recorded data. It's kind of like your bank records when you go to the bank. You can call up your records in the last 3 months, the last 6 months, or even in the last 5 years. And so we think there's a lot of applications for this system, including for insurance claims, and so on and so forth. Because what we're doing here is we're also tracking the movement of the equipment, because in the state of Virginia, they wanted to know if there was actually digging operations that were taking place outside of that ticket area, because there shouldn't be. But they have known in the past that a lot of times there's been digging taking place in areas where perhaps there shouldn't be digging. And a lot of times if they haven't received the information in a timely manner, that's where they're digging blindly, and that's when a lot of times damages result. The other thing we've done here, Mark, can you go ahead and just click on the equipment again? The heavy equipment. Inside our system, we've designed what we call excavation guidance system, which what we're able to do is for the path, if you will, of the equipment, we've designed excavation guidance systems to provide them a damage prevention tool, which gives them an indication of the utility lines in the area, and also provides to them what we call the nearest target record. So the system is always monitoring where the equipment is relative to the utility lines, and it provides the operator at all times an indication of where the nearest utility line is based on the information that the system's been provided on that nearest locate point. So in this case, we have a locate point on that utility line, and where the equipment is relevant to the position of that utility line is 49.92 meters to that point. So it gives them an indication based on when they're traveling. So then what the utility companies can do, or the state can do, is provide to the contractor parameters based on buffer zones on how close they want to permit that equipment to get before they have to go out and actually expose that line. And that could vary based on water line as opposed to a fiber optic line, or say, for example, a gas line. You may not want heavy equipment within, say, 50 meters of a gas line, but you might permit heavy equipment to be within, say, 25 meters of a water line. And all of these things can be changed based on a county level or a state level or a national governmental level. So again, it's a business rules system. The idea here, though, is to obviously reduce the amount of damages that are caused during digging operations by providing a much higher level of awareness as to what lies beneath the ground and then where that information came from, who provided that information, which is based on the metadata inside of the locate device, which you're looking at up here, including job name, the X, Y, and the Z coordinate, the date it was recorded, the time, the line type that was located, what are the GPS vertical and horizontal precision factors based on the equipment being used, and what type of receiver was being used. So what we're doing here is kind of setting standards, if you will, or regulations, which then in turn would dictate, what type of equipment is being used, what level of accuracy is required as far as precision on the GPS, how much information you want entered into the system. The idea being is not only are we going to reduce damages caused during construction, but also as the pedigree of the data increases, or the metadata associated to the locate, once that information is stored in the system, it should reduce the amount of notifications that are required and how many times you have to go back out there and relocate that utility line, which in turn should have tremendous cost savings to the utility company that's actually having to pay for those locates. Once the utility line is located and there is an accepted precision, if you will, or accuracy level of that data being recorded, then they should also be able to reduce the buffer zones. In some cases, because the utility companies themselves do not know with any level of confidence where their utility lines are, if there's going to be digging anywhere around their utility lines, a lot of times they indicate to the one call center, if anybody's digging even within a half a mile of our gas lines, we're going to go out and do a locate because we're not sure where they are. So obviously, as these lines are located and the level of precision is acceptable to the utility company, they can start to decrease the buffer zones around their utility lines based on the locates required, which again is a tremendous cost savings to utility companies. I know when we were working with Piedmont Natural Gas, they were telling us that they spend upwards to $8 million a year on doing locates, and 50% of those locates were not necessary once they went out and located those lines, because in many cases they were actually outside of the dig zone that was proposed by the contractor. So in this case, what we've done is we've integrated into Google Maps. That just happens to be the photography that we're utilizing in this case. We've created an API with Google, which is actually pretty handy because now you can utilize this system off of any mobile device, including even cell phone devices. Mark, why don't you go ahead and click on the satellite imagery. We'll go ahead and bring satellite imagery in. Now again, because it's a database management system, the data that we're showing is only as good as the data inputs. So if we're using Google Maps, you might have a tolerance level as far as the mapping being accurate to say maybe within 30 feet, and depends on what imagery we're using. But we can get to the point where, say for example, if we were doing a government job and they were utilizing subsurface utility engineering requirements, we could use satellite imagery where the resolution is accurate, say, down to 3 feet, which then the tolerance on the imagery is reduced to 3 feet. So each layer of information we have, we also store in the system what we call the pedigree of that information or that layer, which creates a tolerance. So if there's 7 or 8 different layers of information, we actually record the pedigree of each layer, because then that creates a tolerance based on the view. In this case, what they wanted in the state of Virginia is they just wanted to have a topo view relevant to the project site, so whoever was on the construction site could actually see where they're positioned. What I'm going to do, Mark, is I'm going to ask you to drag our little man, like drag the screen down, take our little man, move the map up a little bit so I can see the locates that are down at the bottom. Just move the map up a little bit.
Yeah,
and what we'll do, I'm going to show you now a depiction that if you were a construction worker out in the field, out on this site, or you were a equipment operator, you could drag that little guy right over top of one of those flags. Just take him right over top of one of the flags down at the bottom. We can take you right down to the street level. And then, Mark, go ahead and click on one of the flags. So you can imagine if you were down at the field level and you were actually out on the construction site and you were walking around with your mobile device, or you were an equipment operator inside the equipment and you were digging in the area, what this allows is a visual reference. Say, for example, based on how far away you are from the sidewalk, and then you can click on that flag and it gives you, once again, all of the metadata associated to that locate, which basically gives you an idea if you should be digging in that area or not, or if perhaps as a safety feature you should have somebody come out and actually expose that line. Once that line is exposed, then as Mark showed you previously, we can actually take a visual recording of that, including based on camera or streaming video, and push that to the database too. Okay, Mark, you can go back out to where we were. Now, the system itself is all GPS-centric, so everything we're doing is based on a GPS point. So all of the alignment and everything we do is based on the GPS tolerance. So including locating the line, where the equipment is, the accuracy of the imagery that we're utilizing, all of that is based on GPS and the tolerance within that GPS, so that it gives the user an indication of all the metadata associated to each layer based on a decision that they're going to make. But in most cases, you're not going to be digging too close to a gas line if you know, in fact, there is a gas line in the area without having somebody actually come out and expose that gas line. But the value on our system is once that gas line is exposed, Mark, I'll have you click on the camera again. Then what we can do is once the gas line is exposed, the system will accept, as I mentioned, streaming video, so that if you were in the area the next time and that you couldn't see because they had covered that area, you could actually click on and see what data is available based on that utility line, which would include when it was exposed, we can show you what it looked like, or streaming video. So any data that's been captured on that utility line over time is also stored in the database so that it gives the user a better view, if you will, on exactly what is below the ground so that they can make a much better and more informed decision while they're out in the field if they should or shouldn't be digging in that area. Now in the construction world, a lot of times what these operators want to know is not so much what lies beneath them. They're more interested in what doesn't lie beneath them, because it allows them to kind of speed up their operations as far as digging, as opposed to doing it with their eyes closed and just hoping and praying they don't hit anything. So basically what we've done here today is we're just demonstrating specifically how this system can be used to manage a project life cycle. In this case, we're showing you kind of the steps and the stages associated to state one call systems, going out and locating the utility line, storing that data in the database, and then immediately making that data available to the construction crews so that they know where those utility lines are and where they should or shouldn't be digging. So this tool, as you can see, creates a lot of efficiencies in the way that locates are done and then how that information is pushed up to our database and then made readily available to the construction crews. Now the data in the system, because our system is also a GIS, those utility lines that were located in here, what we would then do is we would then inform the utility companies. Mark, can you click on the blue line for me? What we would do is inform the utility companies that a locate has been done out on this particular area and that this data is now available to them. So they could receive either a voicemail, or they could receive an email, or they could receive a text, depending on how they wanted to receive the data, specifically to who inside their organization needs to receive this notification. In most cases, this would include, say, for example, the GIS department, right down to maybe specifically the person that's responsible for GIS. We make this data available to them. So what they can then do is cross-reference with their GIS system. Say, for example, they're operating in GE Small World, or they're operating in Esri, or maybe they're operating off of a CAD system. We allow them to take a look at this data. They can go in and compare the data that they have in their system. Now keep in mind that up to 80% of most of the data that's stored in these sophisticated GIS systems with the utility companies is actually from paper files. So they know that most of the data in their system is actually not accurate. This is a means now where they can receive a notification that very accurate locates have been done on their utility lines. And if they want, they can go and do a comparison to the data that they have in their GIS systems. And then at a click of a button, they can download this information into their GIS and update their files. We did a project with a large engineering firm for Hillsborough County in Florida, and what they utilized our system for was something different. They actually loaded their entire Esri system up onto our servers, and then were able to take that Esri system, the GIS system, out into the field using our technologies and using mobile devices to view the GIS system out in the field, and then actually go out and visually verify where the assets were on the GIS system, and if they were not accurate. In other words, if they were standing by the fire hydrant and yet on their GIS system running on the mobile device, the fire hydrant on the GIS system said it was on the other side of the street, and where they were standing, they were able to verify it was actually on this side of the street. They could actually correct the position of that asset in real time out in the field, and then push that data up to the GIS system. And then every evening, the GIS manager, who was actually located in North Carolina, would go online, and what he would do is run everything through quality assurance, make sure all the data was collected correctly, take a look at it, and then he would accept it into the GIS system, and then he would push that information to the county GIS system down in Hillsborough, and we were actually able to correct 130,000 asset points that were not correctly in the GIS system. So we were able to verify and rectify all those data points, which had huge impact on all of the other associated business-related decisions that had to be made inside that organization, which had to do with taxes, planning and design, and so on and so forth. So that's to give you another indication of how this system can be used. Basically what it is, it's a spatial GIS system that's set up, it's hosted online, and you can push any amount of data, literally from any device to the system. We can reformat that data, and then we can allow that system to then be pushed back down into those other systems so that they can rectify their records as well. The idea behind the system is to basically create collaboration amongst all the stakeholders that are out there on a daily basis gathering this data, but in most cases it's lost and it's not used again. And yet, just like any data, as you continue to use more and more and more of the data, and you're pushing data to the system and you're tracking the data, then the accuracy of that data will improve over time, which will have a huge impact on how that data can be used. As we know, the U.S. government is getting ready to spend billions of dollars on upgrading our national infrastructure, which includes roads, bridges, highways, and dams. They're going to want to know where all the utility lines are, so that once they expand the infrastructure, if they have to come back 10 or 20 years later to do it again, then they know where those lines are. I mean, there's horror stories out there where they put in huge fiber optic lines, and 20 or 30 minutes later, they're out there and they're digging them back up again because they didn't know where they were when they just finished installing them, and then as soon as they put ground cover over top, nobody knows where they are. We can easily fix that. When we set out to design this in the utility industry, they called this the Holy Grail, because they know that this has been a major problem for years. And now that our infrastructure is actually aging, most of the utility lines that are out there are upwards to 50 years old, is causing a major problem. We saw what happened in San Bruno recently, which had to do with corrosion on a line, and this system can be used for all kinds of things. Once we locate that information, we can push it into GIS systems for doing projections and predictive modeling and so on and so forth. So we think we've designed a very valuable system that can be used for management of various project life cycles. And at this point, what we're looking for is just partnership opportunities to identify what some of those applications may be. So that's kind of where we are. Mark, is there anything else you want to show them on it? I mean, we can go into obviously so many details on this system, but it's a lot of information, and a lot of times when we do demonstrations, we just like to basically just show you the system, and then let people kind of digest that in their mind, and then they usually come back with all kinds of questions on various applications, or maybe some things they saw that they didn't quite understand. And one thing I do want to point out is that we'd be more than happy to do a one-on-one presentation, kind of get down to the granular level, on behind the scenes, if you will, on the technology. If anybody looking at the system today had some more in-depth questions that required some more in-depth answers. I also, just to inform you, I've put together kind of a follow-up overview, which is about a 7 or 8 page brochure, which kind of summarizes everything that we went over today. It gets into a little bit more detail. I try and stay away from the technical granular level, if you will, because sometimes that's like eating chalk. And that is also something that I wanted to point out, Nicole, that if anybody wanted some more information, not just the PowerPoint and the presentation we went over today, but also a document that is kind of a brief overview and gets a little bit more in depth on some of the various applications here and our technology, then I would be more than happy to forward that as well.
Great, yeah, thank you. Those of you who are on the line, when you registered, you had an opportunity. One of the questions was about forwarding your contact information to the presenter. So if you did give that permission, that will be forwarded to Paige and Mark later today, and they can follow up and send that to you. If you selected no in your registration process but still wanted that information, I would suggest Paige and Mark, if you wanted to provide maybe your email address or contact information so folks could reach out to you to get that, that would be great.
Is that, would I forward that over to you, and then you would forward that out, or I'm not sure how
well,
this works?
Even just right now, if you could, do you have a slide or anything with your contact information that folks can jot down how to get in touch with you?
Yeah,
certainly. Yeah, go to the website, and there's also.
Let's just go right. Let Mark go right to the website. That's the other thing too, is our website is a very informative website. It's designed up not so much as a marketing website, but much more as an informative website that explains our technology, who we are, goes into who our teams are, some of the recent developments that we've had, goes into our patents, which we have a very, very extensive patent portfolio. And we have one more patent that has just been issued that I'm waiting to actually receive the actual number from the U.S. Patent Office, and then we are going to notify, if you will, the construction and the utility world of the recent patent that was just issued. But yeah, all of our information is also on the website as well. I'm the contact person, so I'm the person that you would send any request for additional information, or if you wanted to have another meeting or presentation, then I'm the person that you would contact. So I think the best thing to do is just to go ahead and copy that. It's just guardianprostar.com. If you Google Guardian ProStar, we're probably the first 10 pages to Google as well.
Well, great.
I've made a point of making sure that I'm easy to find on the search engines at Google. Nicole, one thing I wanted to say is, and I mean this in all sincerity, is we felt very privileged and honored to even be considered for the FIATech, the CETA award, and it was an honor, and we really do appreciate it. I know that now what it's done is it's kind of opened up an avenue where we have this opportunity now to present to more FIATech members. This is obviously the field that we're interested in exploring, which is the construction and engineering industry. We think that the system that we've designed could have a significant impact in that market sector, and we do really appreciate the fact that you have opened that door for us and allowed us even today to present to those that have expressed an interest in our system, and I mean that with all sincerity.
Oh, well, you're very welcome. The jury that did the selections really felt that this technology integrated well into established business processes, and it also leverages open standards and technologies to really advance and improve our current practices. So we're always looking for new emerging technologies or crossover technologies from other industries that have been successful, and want to highlight that and educate the industry on what's available. So I want to thank you both for taking the hour and presenting this to us. I want to remind those still online that we have recorded this, and we will be posting it on the fiatech.org website under the archived webinars. And just thank everyone again for spending the hour, and have a great week.
That's great. Thank you so much, Mark. I appreciate it. Everybody that's listening, thank you so much for your time. And Nicole, once again, thanks again for facilitating this meeting.
Oh, you bet. Bye, everyone.
Thank you.